We will begin this module by explaining the basic concept of the fly-by-wire system. In conventional aircraft, the movement of the control column is transferred along cables and pulleys until it reaches the control surface to be moved. In the A320 family, however, the cables and pulleys have been replaced by electrical wires. This has the advantage of saving weight on the aircraft. However, there are even greater advantages, as the video clip will demonstrate.
Now the way became clear to reassess the mechanical linkages, transferring the control commands to the electrically actuated hydraulic motors that work the flying surfaces. As electrical signals were already being used to control the motors, the logical step now was to send the message to them direct from the control column by electrical wire, resulting in a far simpler and lighter system. And without the need to exert muscle power, the conventional control yokes could be replaced by small side sticks.
The electrical signals created by side stick movement travel through flight control computers before being passed to the surface hydraulic actuators, also named servo controls. These computers analyze the signal to check that it is a safe command and ensure the optimum flight control surface deflection for the demand. This has advantages over conventional systems. It makes the aircraft extremely stable, enhances safety, reduces the workload of the pilot. Let's now look at the flight control surfaces themselves. The flight control system incorporates ailerons, elevators, a trimmable horizontal stabilizer, THS, for pitch trim, a rudder, ground spoilers, speed brakes. All the flight control surfaces are displayed on the ECAM flight control page. The movements of both ailerons and both elevators are symbolized by a green index moving in front of a white scale. The green rudder symbol is used as an index to display the movements of the rudder on a white scale. The rudder trim is indicated by a small blue line below the scale. Note that the rudder and the pedal deflections are limited as a function of speed via a rudder travel limiter. The high speed position is indicated by small white ticks on the rudder scale. The pitch trim position is indicated by THS deflection in degrees up or down. Let's continue with the spoilers. The spoilers have several functions. Speed brakes use the three central surfaces. Roll control uses the four outer surfaces. Ground spoilers use all surfaces. On the ECAM flight control page, the spoiler extended position is indicated by small arrows. In this illustration, the speed brakes are extended. Now we will look at the flight control computers. The movements of the flight control surfaces are managed by 7 computers. These are 2 elevator and aileron computers, ELAC, 3 spoiler and elevator computers, SEC, 2 flight augmentation computers, FAC. In addition, 2 flight control data concentrator computers are used to acquire data from the ELACs and SECs. Then they send it to the electronic instrument system. The data from both FACs is sent directly to the EIS. The status of ELAC and SEC is indicated on the ECAM flight control page. The other computers are not displayed. We will now see how the hydraulic systems are displayed on this page. 3 independent hydraulic systems are used to power all the flight control surfaces. The hydraulic systems which actuate each control surface are indicated on the ECAM flight control page by the use of G, B, and Y. For example, the rudder is powered by the green, blue, and yellow hydraulic systems. The ECAM flight control page is now complete. Pilots control pitch and roll through 2 side sticks. There are associated side stick priority lights. Side sticks and priority lights will be explained in a separate module. Pitch trim wheels are located on the center pedestal. There are 2 sets of conventional rudder pedals. A rudder trim panel is located on the pedestal. A speed brake lever is located on the left side of the pedestal. In addition, there are 2 panels located on the overhead panel to control the flight control computers. Now we will introduce the lift augmentation devices. There are 5 slats on each leading edge and 2 flaps on each trailing edge. The slats and flaps are hydraulically actuated, like all the other surfaces. They are electrically controlled via 2 slat flap control computers, SFCCs. Each SFCC has 2 channels, one for the flaps and one for the slats. Each channel can drive its associated surfaces. The slats and flaps have protection functions. In particular, surface asymmetry between left and right wings, surface attachment failure, overspeed, or uncommanded movements are detected. Overspeed refers to the movement of the surface rather than the action of IAS, as causing a surface to blow up. The flap lever, located on the right side of the pedestal, operates the slats and flaps. The flap lever has the following positions: 0, 1, 2, 3, and full. The flaps and slats information is shown on the engine warning display. The flap and slat positions are indicated by white dots. Here, the surfaces are extended to position 1 plus F. This is flap 0 indication. Notice there is no labeling with this setting. This is a diagram of the inner workings of the side stick. In the A320 family, manual roll and pitch are controlled by the side sticks. They are spring-loaded to neutral and receive no feedback from the flight controls. Movement of one side stick will not cause movement of the other. In this case, as the left side stick is moved, the right remains in the neutral position. All side stick commands are processed through the flight control computers before being sent to the control surfaces. You can see that as one side stick is pushed forward, the elevators move down in response. If both side sticks are operated at the same time, their deflections are algebraically added together. In this example, as the side sticks are moved in opposite directions, the elevators remain in the neutral position. When both side sticks are moved in the same way, the total demand is never more than the full deflection on only one side stick. Here, as both side sticks are moved forward, the elevators achieve normal full-down deflection, but no more. When either autopilot is engaged, both side sticks lock into their neutral position. Notice that if a pilot applies sufficient force, the side sticks become free, and the autopilot disengages with audio and visual warnings. Move the left side stick. The autopilot has been re-engaged for you. Each side stick is fitted with a red autopilot disconnect and side stick takeover push button. By pressing it, the pilot disconnects the autopilot. Disconnect the autopilot. Notice on the FCU that the autopilot has disconnected. The associated audio and visual warnings can be canceled by pressing the autopilot disconnect push button a second time, or they will stop automatically. A side stick priority logic is also available. Let's study it in more detail. By pressing and holding a takeover push button, a pilot can deactivate the opposite side stick. Audio and visual indications are provided to identify which pilot has control of the aircraft. You are sitting on the left. Take priority.
Priority left.
You heard the audio warning. Notice there is also a red side stick priority arrow in front of the first officer, indicating that his side stick is inoperative. The arrow points left, showing that the captain has control. If the first officer had taken over, the message would have been priority right, and the red arrow in front of the captain would have eliminated. To see what happens when the deactivated side stick is moved, move the first officer's side stick. A green light illuminates in front of the pilot who has the aircraft control. Here, Captain. As soon as the deactivated side stick is returned to neutral, the green light extinguishes. If both pilots press their takeover push buttons, the pilot who pushes last, even by a split second, gets the priority. If it is necessary to deactivate the opposite side stick permanently, press and hold the takeover push button for at least 30 seconds. If a stick has been temporarily deactivated, it will be restored as soon as the pilot in control releases his button. If a stick has been fully deactivated, it may be restored by pressing the takeover switch on either side stick. In either case, notice that both side stick priority lights are extinguished.